Swifter, it's the Power Hour. We're going to get hourly weather data from DarkSky. It's complex nested JSON that includes an array, but we're going to issue this as a challenge because you've already done this using daily data. So we'll use that as our template as we go after the hourly data. We'll describe the challenge first, then give it a try, and we'll show the solution afterward. Giddy up! So here's a look at what we'll be creating over the next two videos. We're going to be adding a horizontal scrolling area. This is called a collection view. And in the way that we got the daily weather forecasts and put them in the vertically scrolling table view, we'll have our hourly forecasts in the horizontally scrolling collection view. Now you can see it holds 24 hours of forecast data, and if there's a 20% or greater chance of rain, we'll show an icon with a raindrop, and we'll list the likelihood of precipitation next to it. So it looks like we got a strong chance of rain at 3 p.m. here in Boston. If I scroll over to San Francisco, you can see the time change. So I was 2 p.m. in Boston. I'm 3 hours ahead of San Francisco, which is why it starts at 11 a.m. here. If I swipe over to Georgia Tech, I can see that it's going to be rainy this evening. Now the symbols that you see in our selection view are from Apple's SF symbol set, and that's accessible from within Xcode. Now, we'll eventually get the collection view working, and we're going to focus on that in the next video. But in this video, we have to get our hourly weather data. And we're going to get it in a way that mimics how we got our daily weather data. And in fact, we'll be able to set this up as a challenge. So just let's review the data that we currently have. So here's the JSON. We decode all of our JSON data into a response struct named lowercase response. And now time zone is at the very first level of JSON that you see here. So that's why the time zone property is the very first level of our response property. Now we also get time and temperature, and those are inside of currently, you see here in the JSON. So we created this currently data structure that's upper camel case currently, and inside it has a temperature and a time property, just like our JSON over here. And we added a currently property of type upper camel case currently into our response type, and this allows us to jump into currently and then get the temperature and time. Now daily is pretty similar. It's also in one level like currently, and we get summary and icon from inside of daily, so we created a daily struct type. Then we added the daily property to response. Now also inside of daily is an array named data, and that has the daily weather forecast. So when we look at our app, the stuff in the table view, the forecast for the individual days of the week, comes from this JSON array that's named data. And to get that, we had to create a data structure that can hold each element of the data array. So that's what daily data is here. It can hold icon name, time, summary, high and low temperature, and then inside of daily, we declare an array named data. It has to have the same name as the JSON key. So that's why we named this property lowercase data. And its type is an array of daily data, and it will grab as many elements as there are elements of this data in the JSON, and that'll give us our weekly forecast at this location. And so to get hourly data, we're going to need an hourly data struct, just like we have a daily data struct. And that's going to hold elements of data that's inside of hourly, just like this data is inside of daily. And then we have to add this hourly property to response that holds the hourly struct. So in your challenge, you can take a look at what we did with data here and repeat pretty much the same thing, but with slightly different values for hourly, but it's even at the same level. So here's our challenge. You're going to create data structures to read and print hourly data, just like we did with our daily data. So we're going to read in hourly data from DarkSky's JSON and then print these results to the console, just like we did with daily. So for example, here you can see that the hour is 11 p.m., the icon is clear night, the temperature is 39, and the precip probability is 0. This is our hourly data. We're going to grab the array that's inside of its data key here, and we'll print that out. Now to do this, we're going to leverage what we already have done with daily. So we're going to create an hourly variable, just like we've got a daily variable. We're going to make it of type hourly. Now in this hourly struct that we defined, it's going to be very similar to the daily struct that we defined. This is going to be codable. It's going to be private. Now it's only going to have one variable, and that's the data value here. So this is hourly. We don't care about the summary and the icon here for hourly. What we want to do is we want to jump directly into data. So hourly is just going to have one element, data. And now data is going to be an array of hourly data. Now hourly data is going to be the array that we create, just like we've got daily data, but hourly data is going to hold the hourly time, icon, precip, probability, and temperature. And these are the types for those things: string, time interval, double, and double. Now at this point you will have gotten everything into the response property that we're using locally inside of weather detail, but there's one more piece here. Now, in our daily data, we didn't leave it inside of response, daily, and then data. We extracted it. We put it inside of an array inside of weather detail that was called daily weather data, and that's an array of type daily weather, which is a struct at the top of our weather detail. So it's in the weather detail file, but it's not in the weather detail class. So for our hourly data, we're going to do the same thing. We're first going to create a struct called hourly weather. We're going to put that above the existing class. So it'll be a peer, meaning it's at the same level as our daily weather struct. And that's going to hold the converted data that we get from the data array inside of the hourly key that's inside of our response. And so each element of hourly weather should have the hour, which is going to be the string for the time, like 1 p.m., 2 p.m., 3 p.m., hourly icon, which is going to be a string for the icon that we should show, hourly temperature, which is going to be an int for the temperature of that hour, hourly precip probability, which is going to be a percentage from 0 to 100, an int, that's going to be the likelihood that there will be rain or some other kind of precipitation during that hour. Now we'll be getting that data from inside of the data array that's inside of hourly. So the data is slightly different. Some of the things that we need to do are the precip probability that you'll see in here is actually recorded by DarkSky as anywhere from 0.0 to 1.0. So we're going to need to multiply this by 100 before we convert it to an int. For hourly data time, we're going to create a new date formatter that's going to be an hourly formatter. And instead of the current one that has the date format EEEE, this is going to have lowercase h, lowercase a with nothing in between. That's going to show hours plus AM or PM. Then we'll declare an array inside of weather detail named hourly weather data. So just like we have a daily weather data, we're going to have an hourly weather data. This is going to be an array of type hourly weather, just like daily weather data is an array of type daily weather. And that's going to hold our hourly data. So that was a lot of explanation, but it's actually pretty straightforward. So in the way that we've got daily and then data, this array of data inside, we need to go inside of hourly and get the array of hourly weather data that's inside of this data key. And we're not interested in hourly summary or icon, just the data key, those elements of this array here. But inside of this, for each hour, we want to make sure that we get time, the icon, the precip probability, and the temperature. So as usual, just before you do a challenge, you probably want to make sure that you commit and push. Just in case something goes wrong, you can go back and get the last working version of your project. And here's the challenge slide so that you can review this as you try this on your own. So pause, give it your best shot, Swifter. Use what you've done with daily so far as your model, and resume. Let's see how you did. So all the work that we'll be doing in this video is going to be inside of weatherdetail.swift. Now we want to mimic what we've done with daily. So if we take a look at response, we can see that there's a daily variable that's part of a daily data structure. Down here we can see the daily data structure, and we can see inside that has a variable called data, which is an array of daily data. So we need to repeat this with our hourly data. So in the way that we've got a struct named daily, let's create a struct called hourly. We'll say private struct hourly, that's upper camel case because this is the struct, colon, codable, open and close curlies. Now our hourly data struct is only going to have one variable. It's going to be data, that's lowercase data, and this name is the same as the key name that's inside of our JSON. And we're going to say var data colon, and then this is going to be an array of hourly data. So we need to create that struct too. And again, hourly is mimicking what we've got with daily just above it. So now in the way that we've got this guy daily data up here, I'll just copy this, paste it down below, close the curly, and we'll change daily data to hourly data. Inside, we're going to have time, icon, precip probability, and temperature. So we'll add var time colon time interval, that's a Unix date, var icon colon string, var, and let's just tab over to make sure that we're spelling precip probability correctly. I'm going to copy this, and I'll paste precip probability in, colon, that's a double, and then var temperature colon, that's a double as well. So now that we've set up our hourly data structures, let's go up to response, and right under daily, we'll say var hourly colon, and that'll be capital hourly, the struct we just created. So now let's head back down to our getData function inside the do try catch loop, and you can see where we've used a for loop to go through all of the elements in response.daily.data. Well, we want to do the exact same thing down here, but we want to go through response.hourly.data. So just like this loop above, we're going to say for index in 0 ... less than response.hourly.data.count open and close curlies. And if you take a look at what we did in the loop above, so we created a bunch of constants, then we created a daily weather data structure, and we appended that to daily weather data. So we don't have an equivalent of an hourly weather data structure, so we got to go create that up top. So right under our daily weather struct, we'll say struct hourly weather codable open and close curlies, and we'll add our properties. Var hour string, var hourly icon string, var hourly temperature int, and var hourly precip probability int. And we could use any name for these variables because we're not decoding directly from JSON here. In fact, we don't even need codable in front of hourly weather and daily weather. We'll cut that out later on. And now just above our getData function, we see we have a property daily weather data, and this holds the data for our table view. So let's create a similar property just below it that will hold our collection view data. That's the hourly weather data. So we'll just say var hourly weather data and then in brackets it'll be hourly weather, that struct we just created, and we'll make that equal to empty bracket so that it starts out as an empty array. But now we've got this data structure that we can fill up with the data that we're getting in our for loop as we go through response hourly data. Now our date formatter converted the date to show just the weekday, and that's what the date formatter value EEE does. So in order to show the hourly data, we want to see just the hour and AM or PM. So I'm going to create a new date formatter. I'm going to highlight the date formatter above, copy it, paste it below. We'll change the name from date formatter to hourly formatter. Then I'm going to replace the 4 capital E's with just lowercase ha. Ha! That's what gives us an hour in either AM or PM. And you can look up the pattern on the table that we saw in the previous video, but trust me, this is going to work. And we could keep the name inside the function as date formatters because it's just recognized between the curlies, but I'll change it all to hourly formatter just to underscore that this is something different from the one above it. And I'll modify the print statement here as well so that it says I just created an hourly formatter, and I'll get rid of the calendar emojis and replace these with a couple of clocks. And now that we've got our hourly weather data property set up, we're ready to go and get our hourly data from response. So we'll start by converting our Unix date into an Apple date. We'll call that hourly date. So we'll say let hourly date equals date and select time interval since 1970. And we'll pass in response.hourly.data bracket index close bracket .time. And now let's set up our hourly formatter so that it knows about the time zone. So we'll say hourly formatter dot time zone equals upper camel case time zone, open bracket, select the identifier option, and I'll just copy response.timezone from up here and paste it down here. So again, you can see how we're mimicking what we did in daily data with hourly data. So now let's use the hourly date, run it through the hourly formatter, and get a string that lists just the hour and AM or PM. So we'll call that hour, we'll say let hour equals hourly formatter dot string, and this option with from in here will pass in our hourly date. And that's our now valid Apple date that we got from our Unix date. Now let's get the string that's going to hold the icon name. So we'll say let hourly icon equal response.hourly.data open bracket index close bracket dot icon. And now let's get that probability of precipitation. We'll say let precip probability equal response.hourly.data bracket index close bracket dot precip probability. But if we take a look at the DarkSky API documentation, it says that this is the probability of precipitation between 0 and 1 inclusive. That's not what we want. We want it to be as a percentage from 0 to 100. But that math is easy. Multiply it by 100, round it up or down, and then convert it to an int. So we'll say, right after precip probability, star 100, wrap these results in parentheses, then say dot rounded, open and close parens, so that will move it either up or down depending on if the decimal is 0.5 or higher for rounding up, otherwise it'll round down. Then we'll proceed this statement with an int, and wrap it in parentheses to convert the whole thing, which is a double, into that int. And take a good look at this statement to make sure that you have the right number of parentheses. Things are getting a little complex in here. It's int paren, then one close paren after 100. Then we say dot rounded, open and close parens, and one more close parens to end the int type conversion. Unsure of the math? Remember, you can always open up a playground and try it out. And then let's set up the temperature, and that'll be converted to an int. So we'll say let temperature equals int open parens, response.hourly.data, open bracket index, close bracket, dot temperature, dot rounded, open and close parens. Now that we've got all four constants set up to create an instance of hourly weather, we will say let lower camel case hourly weather equals upper camel case hourly weather, open parens, select the option with all the parameters in here, hour equals hour, hourly icon equals hourly icon, hourly temperature equals temperature, and hourly precip probability equals precip probability. And now let's append this bad boy to hourly weather data. So we'll say self.hourlyweatherdata.append and pass in hourly weather. And now let's print out the results, make sure that we've got everything we're expecting. So we'll say print, open parens, and in between the double quotes we'll say hour colon string interp, comma, icon colon string interp, comma, temperature colon string interp, comma, precip probability colon string interp. And in the string interps, we'll put in our four hourly weather values. So hourly weather.hour, for icon hourly weather.hourly icon, for temperature hourly weather.hourly temperature, and for precip probability hourly weather.hourly precip probability. Then we'll build and run. I'm going to go into my location list and I'm going to click on Boston College because if I swipe left or right, sometimes iOS will preload some of the pages, and in that case, the hourly data in the console wouldn't be the data for the location I'm looking at in the view controller. But if I click right on Boston College, I'll see BC's hourly weather. I'll move the simulator over to my left, but if I look at my simulator, it says it's currently 67 degrees. If I take a look at my time in the upper right-hand corner, it says it's 5:04. And in the console, DarkSky is actually giving us 48 hours of hourly weather data. But here I am, just at the start, I can see the hour is at 5 o'clock, which is the current hour. It's 67. I can see 6 o'clock it goes down to 66. At 7 o'clock it goes down to 65. So this has got the proper weather data. Excellent job, Swifter. Next video, we'll learn how to set up the collection view. Keep at it.